Here's a sample application that I'm going to be using in order to explore the inheritance features of C#. So what I have open here is a customer class. It's in the OOP Techniques, that's the name of the project, in the OOP Techniques namespace. And I have a customer class that defines various properties that define the core functionality of a customer. All right, and so then I implement various things. There's some constructors, the various properties, some limitations on the properties, some validation and so forth, and a few methods in order to get information, record sales, and retrieve information about the customer. And I'll be exploring most of this code as we go along. So here's a corporate customer class. The important thing here is that this is a derived class. It derives from the base customer class. And then here's an individual customer that also derives from the customer base class, but has its own characteristics. For example, it has birthday information that a corporate customer doesn't have. All right, so this is the syntax for defining this relationship between classes that defines inheritance. So I use the class keyword, just like creating any other class, some valid C# identifier name, in this case corporate customer, followed by a colon, followed by the name of the base class. All right, so this defines the relationship between these two classes, the derived class, corporate customer, and the base customer class. And I do the same thing over here for the individual customer. Now, one thing to be aware of, particularly if you're looking at code from the .NET framework or other code that someone else has written, is that this same syntax is used to indicate that a class implements an interface. I'm not going to talk about interfaces right now, but just be aware that you can have a single inheritance relationship, but you can have multiple interfaces. And in fact, if this class only implemented an interface, it might not be entirely clear whether this is an inheritance relationship or if it's implementing an interface. But one of the things you can do is hover over this object here and see that this is a class. Oh, it's a class, so this is an inheritance relationship. If it said interface instead, then it's implementing that interface. And you can both derive from a base class and implement interfaces, in which case you first have the base class and then a comma delimited list of whatever interfaces are defined. All right, so just be aware of that syntactical kind of oddity. But once you get used to it, it's pretty straightforward. And the biggest way to tell is that the convention in the .NET framework, one that I urge you to follow yourself, is that interfaces are virtually always, their names are always prefixed with a capital I. So if I was going to implement a customer interface, it would be called capital I, capital C, lowercase I customer. So that's a quick and easy way to see the difference if people consistently use that convention. Okay, then over here in my main, calling for my main method, is some code that uses those classes. So this looks quite similar to the generic code that I just used the customer class, but this time now it's using the corporate customer. But I'm using the same properties, I'm using the same methods of the base customer class in this particular code. Now, just to be clear, if I come back over here, corporate customers has a record sales method, but notice that it has 1, 2, 3, 4 parameters. But the method that I'm calling both places here and both places here use only 3 parameters. And so this is calling the version of record sales that's in the base class. Okay, so that's a distinction there. What's important about this code here is that each of the derived classes inherits the properties and methods of the customer class. And so they both have a customer name property and a record sales method. Even though I'm calling them on corporate customer and individual customer, Customer name isn't implemented in corporate and individual customer. I'm actually calling the base class functionality. Same thing with record sales. So this is known as polymorphism. Polymorphism enables you to define multiple classes that have properties and methods with the same name, but potentially different functionality. Then you can write code that uses these classes interchangeably. So I always know that I'm going to have a record sales method that takes 3 parameters, and I can use that in my calling code. Also, each of the classes provides a customer name property, or uses a customer name property. You call this property the same way for each class. Again, you're calling it here on the derived class, an object of the derived class type. But because the base class has customer name defined, I can call it directly, but I don't need to implement it within corporate customer and individual customer. I can, but I don't need to. And more importantly, this code that is using the class doesn't need to know how the class implements the property, whether it's implemented on the derived class or the base class, or what code it's executing in that property or method. All you need to know as a user of these objects is that customer name takes and returns a string. The code in the class definition doesn't affect how you use the property in calling code. Now, the benefit of polymorphism is that it insulates you from the differences in the inner workings of a property or method. When you call the customer name property in your code, you just expect it to work a certain way, regardless of whether you're using an instance of the customer, corporate customer, or individual customer classes, and regardless of whether either of the derived classes implements the property differently by overriding it. Okay, so at this level of use, as this code is using those classes, the 2 derived classes contain the same members. Next, you'll want to decide how the 2 derived classes differ from one another. What properties and methods do they have in common? These can stay in the customer class. What properties and methods are unique to each of the derived classes? Then you'll need to add those to the derived class, whichever is appropriate. Corporate related features to the corporate customer, and individual related features to the individual customer. Okay, so for example, if we take a look at the corporate customer, notice that it defines a couple of fields, a private _ sales rep and an _ credit limit. Because corporate customers typically have sales representatives who are their personal contact in the company, in our company, in order to facilitate sales, because they're buying lots of stuff. And then we also may extend them a credit limit that this particular company doesn't extend to individual customers. Obviously, different companies work differently, but let's go with this as a concept here. Okay, so in order to implement those properties, we have to define them. So here's a sales rep property. It's implemented as read-write. Here's a credit limit property. It's also implemented as a read-write. But it also has a change credit limit method that allows you to call the method and indicate the amount that the credit limit is changed by. So if this current customer has $1 million credit limit and we want to give them $500,000 more, we call change credit limit with a positive $500,000, and their credit limit gets updated. Or if it goes down, we could pass in negative $500,000 and it'll go down by $500,000. So again, this is functionality that is unique to corporate customers. So it's appropriate to implement it in the derived corporate customer class. Then I can come back over here and instantiate a new corporate customer object, set the customer name to Biggie Industries, and then directly use the sales rep and credit limit properties. So what's different about the previous code that I showed you here is that these properties and methods I was actually using the properties and methods of the base class. Here I'm still using a property of the base class, but now I'm using two properties of the derived class, because these are implemented within corporate customer. And then I can go further. I can call record sales there. Again, I'm passing in 3 parameters. So this is, here I'm calling the record sales method of the base class, the base customer class. But here I'm calling a method of the derived class. And I'm going to change the credit limit by this amount. So that's $100,000. And I'm dividing by 10, converting it to an integer because this takes an integer value. And that is going to add $50,000, or no, I'm sorry, $5,000 to this company's credit limit. And then I can also read the customers. So I'm going to display something out to the console window here. And I'm going to say sales rep, whatever the sales rep's name is, it'll be Ed, says that the customer's credit limit is now whatever that total credit limit is. So I change the credit limit here, and this is displaying now the credit limit property. So I'm reading this property of the derived class. All right, so if I run this code, I'll select added members. And so far, this is the only code I've talked about. So Ed, the sales rep, says this customer's credit limit is now $110,000. Okay, so you can see how seamless it is in this code that uses this derived class to use both the members of the base class as well as the derived class. Again, this code at this level, the developer who's using the corporate customer class that you created doesn't have any idea where these features are implemented. It's completely opaque to that developer. Developer doesn't need to know. That developer is a specialist on user interfaces, doesn't need to know about the inner workings of your corporate customer class. Okay, so let's look at the individual customer. Also, we can add some unique features here that are particular to individual customers. So in this case, we want to be able to record the customer's first name and last name, as well as their birth month and day. Don't need the year. And then also have an index, and I'll talk more about that shortly. Okay, so here are the backing fields for those properties, and here are the implementation of those properties. Okay, first name, last name. I also have a method for customer name. And what's interesting here is that I'm actually defining a method that lets me write an individual's name to customer name. So I could assign a full name, like Don Kiley, to the customer name property, and it'll take care of splitting it out and assigning first name and last name. All right, now this is very simplistic code. It doesn't handle if I pass in Donald Paul Kiley or Donald Harold Kiley or whatever, or if my name was Donald Van Kiley and Van was separated by a space. Okay, keeping the code simple, but the point here is that we're implementing this customer name in order to allow that kind of functionality. And I'll actually talk a little bit more about that later. All right, and then we have the birthday month and birthday day. All right, so these are unique properties of the individual customer derived class. And then the rest of the code here exercises that object. So I have an individual customer. I'm setting the first name property to John, last name to Smith. I'm also using that customer name property to again set the same values. So this is actually redundant to these right here, but shows that it can be done. Setting the birthday month to May 30th. And so these are unique features, all of which are implemented in the derived class, including customer name. And again, I'll talk more about that a little bit later. But the idea here is that I've overridden the base class functionality. Because customer name didn't quite work for an individual customer, I'm able to override it. All right, and then the code goes on to define an amount. And it checks to see if today, the month today, is the birthday month of the customer, and if the day today, the 1st, 2nd, 3rd, 4th, 5th, whatever day of the month, is equal to the customer's birthday day. And if it is, we're going to give that customer a 20% discount. Just flat out multiply the amount by 0.8 and tell the customer that they get a 20% discount today. Otherwise, going to say, sorry, Don, John, whoever, no discount today. And then it's going to record the sale. Either $100 for if it's not their birthday, or $80 if it is their birthday. Okay, I'll run the application again and do C. And as you can see, it says, sorry John, no discount today. Today happens not to be May 30th. And because John's birthday is on May 30th, the only day of the year that the amount will be discounted for John Smith is going to be on May 30th.